Yes, good evening students. Hope all of you are in a preparation mood. So here we are here to help you from chemistry side. You have a board exam coming soon. So we are here to help you for board exam. Okay, so we are doing the objective questions. We are concentrating on objective sessions. The students find very hard with objective questions. So today we are starting with haloalkanes and haloarenes, as well as chemical kinetics. Myself is Mahesh, and here it is Ishaq sir, and he will start with the chemical kinetics. You can enjoy the session. Okay, I'm telling.
Thank you.
Ishaq sir. Okay.
Thanks, sir, for warm welcome for me. Yeah, can I start? Yeah, Sean. I don't know how much you have been in my life since it's not a Zoom session. Can I have a thumb from your side? I don't know how much people are in the live the regarding and all. It's not a Zoom, right? So can I just a thumb, something like that? You are here. I want to make sure that my kids are here. Please. Yeah. Miva, yeah, sure. Can those who are watching here the live? Yeah, Yuva. Yeah, thanks, Yuva. Any more guys from here? Yuva, sure. Miva, yes. Can I start? Abid, yeah, sure, Abid. Thank you. Abid, DPS, right? Yeah, Square, I don't know. Let's some more. I need some more. I need some more energy, please. Nabil, okay, sure. Adnan, sure. Abdullah, fine. Yes, yeah, Abid. Yeah, sure. Yes, you are. Yeah, I'm starting. Thanks all for your comments and all. I'm starting question number 1. It's actually regarding the chemical kinetics chapter. See, you may see this question in my module test and all. I mean our Excel module test and all. Let's try to solve this one here, right? Question number 1, it's related with actually instantaneous rate of the reaction. Yeah, you are. Yeah, sure. So question number 1 is actually given that 2NH3 giving N2 plus 3H2. They given that minus d by dt of concentration of NH3 is equal to K1 into concentration of NH3, d by dt of N2 is equal to K2 into concentration of NH3, and d by dt of H2 as K3 into concentration of NH3. What we have to do means we have to derive a relationship between K1, K2. You may see this actually in the previous NEET session, but I hope may repeat in board 2. Let's try the question number 1. So given that 2NH3 giving, the given question is 2NH3 giving N2 plus 3H2. Since related with d by dt means it's called what we can say instantaneous rate. So go with the instant rate equation. Since it's 2NH3 giving N2 plus 3H2, NH3 is the reactant, N2H2 are the product. Go with the instantaneous rate equation. R is equal to 2 is the coefficient will be coming reciprocal called 1 by 2. Since it's a reactant, use negative sign minus d by dt of NH3, which is equal to coefficient of N2 is 1, reciprocal is 1 by 1, it is 1. Since it's a product, yes, albene. Then it's a product, so we can use plus sign into d by dt of N2, which is equal to coefficient of H2 is 3, will be coming reciprocal called 1 by 3. So 1 by 3, since it's a product, you can use plus sign plus 1 by 3 into d by dt of H2. Okay, see, you can say that here given minus d by dt of NH3 is K1 into concentration of, that means a term called minus 1 by t into d by d. You can take 1 by 2 out. Remaining is d by dt of NH3. It is same as what? K1 into concentration of NH3, which is equal to d by dt of N2, given that same as K2 into concentration of NH3, which is equal to 1 by 3 into d by dt of H2. Assure that 1 by 3 into d by dt of H2 is same as K3 into concentration of NH3. You can cancel this all NH3 over here. It's common in all free. You can cancel all this concentration of NH3. So remaining will be what? K1 divided by 2 is equal to K2 into 1 by 3 into K3 same as K3 by 3. But unfortunately options, unfortunately options are not available here. So we'll do what? Just create an option. Anyway, K1 equal to K2 will be wrong because K1 by 2 is K2. So option A will be obviously wrong. What about option B? K1 equal to 3 KH2. Sure, it will be wrong, Zuhra. So I can cancel that second option 2. Now we have to go with option either C or option D. So let's make it either option C or option D multiplied by 3, I guess, because multiplied by 3 overall reaction, you will get 3 by 2. 3 by 2 is 1.5. So okay, 1.5 K1. 3 will be coming here also, will become 3 K2. And 3 will be come here also, but 3 get cancelled, remaining will be K3. So 1.5 K1 equal to 3 K2 plus K3, or sure option. It's option C, right? It's option C, Hiba, not option D, right? 1.5 K1 equal to 3 K2 equal to K3 means go with option C. First question C is right answer. Hope you are fine. Yeah, Abdurrahman. Sure. Yeah, Dia. So I hope first question is fine for you. We have to finish within 10 questions, within some just rushing for the next question for you. Question number 2, please. Question number 2. Rate law for the reaction given as A plus 2B giving C. Rate law for the reaction given as A plus 2B giving C is found to be rate is equal to K into concentration of A into concentration of B. Okay, it's a good question. Alan, concentration of B is doubled. Concentration of B is doubled means you can say B will become 2B. Okay, B will become 2B. And keeping the concentration of A constant, the value of rate constant will be, usually people may go with option, people may go with option, I guess, option B, because they think like this: if concentration of B is double, rate will be also. But the thing is, they're asking rate constant. See, rate constant depends, the value of rate constant depends only on temperature. If temperature remains same, if you may change in concentration, pressure, whatever may be, rate constant remains to be con, because rate constant depends only on temperature. I guess people may go with option B because they think like this: if concentration of B doubled, B become 2B, so R will become 2, but it's wrong. Why? Because here they're asking about rate constant. It's a constant, or it depends only on temperature. Whatever may be the Amina, Muhammad, yes. So whatever the change in concentration made, rate constant will become a constant, depends only on temperature. Go with option A, sure, Muhammad, Amina, obviously correct. So, going for question number 3, please. For a complex reaction, order of overall reaction is equal to molecularity of the slowest step of the reaction. Sean, see, what is meant by order and molecularity, or what is meant by elementary and complex reaction? The reaction taken place in single step is called elementary reaction. More than one step is called as complex reaction. For a complex reaction, molecularity has no meaning, but I can say for a complex reaction, molecularity has no meaning, but order will depend upon rate of the slow, or depend only on slower step. For example, we have reaction called A giving C, imagine, or A giving B, A giving C. Assumed to be a complex reaction. Complex means taken place in more than, tricky, suction. It's a complex reaction, take place in more than one step. Okay, let's step number 1, I'm calling it as A giving B. Step number 1, I'm calling it as A giving B. And step number 2, I'm calling it as B giving C. Okay, overall reaction is A giving C. It's a complex reaction. Complex reaction means take place in more than one step. Each step in a complex is called elementary fact, that you know, I guess. But the thing is that for a complex reaction, molecularity has no meaning, but rate determining upon the or you can say the in a complex reaction, molecularity has no meaning, okay, but order depends upon the slower step, or rate determining step of a complex, that will be the slower step. Here A plus B, so A giving C, okay. Step number 1, I'm calling it as A, suppose it was slower step, okay. A giving B is a slower step, and B giving C is the fastest step. You can say it's a complex reaction, take place in more than one step, okay. The rate of A, or you can say rate of a complex depends upon only the slower step. Slow step is A giving B. And just one more thing, molecularity of the slower step will be same as order of the overall reaction. That's a key point for you. For reaction A giving B is a slower step, okay. Molecularity of A is 1. That same will be the order of the overall reaction. So I can say the Rate law will be coming like R is equal to K into concentration of A raised to 1 because it is coefficient is 1. So concluding my point is, there we go. Concluding my point is, reaction take place in single step is called elementary. More than one step is called complex reaction. For a complex reaction, molecularity has no meaning, but order of a complex reaction depends upon rate of the slower step or depends upon slower step. And one more thing, molecularity of the slower step will be same as order of the reaction. Here the slower step is A giving B, molecularity is 1, same as order. Now going for the Hula. Now going for assertion. For a complex reaction, order of overall reaction is equal to molecularity. Absolutely correct, because order of the complex reaction will be same as molecularity, number of molecules of slow step. Obviously assertion correct. What about reason? Rate of a complex reaction controlled by slower step, damn sure, and select the most appropriate answer from the following option. So we can say what? Here both assertion, reason will be true, and reason is a correct explanation. You can go with option A. I hope it is clear. Yes or no, please? Absolutely. Yeah. Mohammed, sure. Hula. Can I continue? Reem, sure. Going for next question. It's actually regarding CH3COOC2H5 plus H2O in presence of H plus giving CH3COH plus C2H5OH. This one will not be there. Tell me, it belongs to which one? I think the question may be, what's the order of the reaction? Tell me what's the order of this reaction. It may be either option A called 0 or option B called second order, option C third, and option C pseudo first order. Any idea? Albin, Rehan, first, Saksham. Give me the answer. Question is good. Okay, give me your option B about A, B, C, D. Saksham. What do you say? Yeah. It's actually called hydrolysis of ester. Hydrolysis of ester is a yes, Muhammad. Saksham, Razal. Yeah, good. Yeah. It's option D, sure. Who is that? Prabhakiran, Sudan. Yeah, it's option because it's called hydrolysis of ester. Hydrolysis of ester is coming under pseudo first order reaction. What is pseudo first order reaction? Some reactions are expected to be higher order but follows first order under certain condition. Condition will be one of the reactant will present in excess amounts. So obviously you can say option D because it's a hydrolysis of ester reaction. It's coming under a category called pseudo first order. So it's option D. Can you give me one more example pseudo order, please? Any one of you? Give me one more example of pseudo order reaction, please. Give one more example for pseudo reaction. Let's fill the comment box. Tell me. Hey, Saksham, Muhammad, Rehan. Give me say one more example for a pseudo order reaction. A, inversion of cane sugar, right? Yes, it's also pseudo first order reaction. That is inversion of cane sugar. Sure. Muhammad Ali. It's cane sugar. I mean, especially inversion of cane sugar. Question number next one, please. For a first order reaction, the graph of Devika, Mustaqim, Saksham, yes. For a first order reaction, graph of log A versus time is given below. Log A versus time is given. Slope is x. What is x is equal when slope is what is the question? Let's try. First of all, create equation in the form of y is equal to mx plus. It's a first order reaction. For a first order reaction, I can say the integrated rate equation will be time t is equal to 2.303 divided by k log of r0 by r. It's a first order reaction, so equation ready with you. So because given first order, time t is equal to 2.303 by k log r0 by r. Create equation in the form of y is equal to mx plus c. Is Abid sure? Yeah, go with option. Okay. So hey Abid, check. Recheck Abid. Yeah, Abid, now it's okay. So create equation in the form of y is equal to mx plus c. On cross multiply, k will come here. You will get kt or tk or kt is equal to 2.303 into log of r0 by a. From here, what we can say? Log r0 by r, it will come down kt divided by 2.303. So kt divided by 2.303 is equal to log of r0 by r. Log of r0 by r means log of a by b. There we go. Log of a by b. So we'll be getting kt divided by 2.303 is equal to log a by b. Log a by b is log a minus log b. So log r0 minus log r. We need to get equation in the form of log R, same as log A. A means reactant, same logic, right? We have to create in terms of log A and time. So I'll keep log R over this side. You will get like log R is equal to on moving that side log R0 KT divided by 2.03, moving that side will become minus KT divided by 2.303. Just rearrange to get the form of y is equal to mx plus c. Getting log R is equal to log R0 minus KT by 2. It's same as Haloarenes. It is same as minus KT divided by 2.303 plus log of R. Now it is exactly of the pattern called y is equal to mx plus c. So y-axis will be having log R, okay. X-axis will be having time, okay. The slope is called what? Minus k divided by 2.303. Go with option C is the right answer. Sure. Razal, Adarsh, Devika, Afreen, Hiba, fine. Now, next one, please. Question: a reaction proceeds by first order. 75% of the reaction was completed in 32 minutes. Then the time required for 50% completion is, you can do it in many ways. I'll show one way, okay. So here given that it's a first order reaction. Since it's a first order reaction, the integrated rate equation will be time t is equal to 2.303 by k log of R0 by R. So they given that time taken to finish 75% of the reaction is 32 minutes. Okay, fine, cool. Sure. Yeah, we can do the end of block also. Sure, man. Muhammad Abel. We'll do all chapter, bro. We can do all the 10 chapters. We are starting from year 2. We'll do the end of everything. Okay. So it's t is equal to 2.303 by k log of R0 by R. So here, given that 75% of the reaction completed in 32, what is the time required to find out the 75% means? You can say T75 or 75% completion is equal to 2.303 by k, nothing mentioned about k, so keep it k as such, fine, no issue. Log of R0 by R, it's a percentage question. For percentage question, R0 will be 100, okay, divided by R. What is R called? R is the concentration of the remaining reactant. Since 75% is completed, means remaining will be 25%, so 100 by 25, okay, cool. Here given that time taken for 75 is 32, means so we can say 32 is a time taken for 75, which is equal to 2.303 by k. Log of 100 by 25 is same as log 4. Okay, keep it over there. Wait. Actually, the question is what? Time required for 50%. Go with time for 50%. Apply the same formula. How will get time required for 50%, children? Formula 2.303 by k. K, nothing mentioned. Keep it k itself, fine. And the log of R0 by R. R0 for a percentage question will be 100. Divided by R. R is the concentration of the remaining reactant. Since 50% completed means remaining will be again 50. So T50 is equal to 2.303 by k. Log of 100 by 50 will be same as log 2. And what we required is time taken to finish 50%. That T50 is my question. I'll call this one as equation number 1 and this one as equation number 2. Rearrange it, get the value of, or you can find out k from here, solve it's okay, fine. What we require is time taken for 50%. Either you can find out the k value from here, put it's fine, or one more option I can give you. But it's MCQ, we can go in some advanced way. We can do equation 1 divided by 2, okay? On doing equation 1 by 2, LHS by LHS, RHS by RHS. LHS contain time taken for 50% that we have to find out. By time taken for 75 is 32 is equal to. Here RHS contain 2.303 by k log of 2 on RHS. Here RHS contains what? 2.303 divided by k into log 4. Okay. So 2.303 by k, 2.03 by k cancel. Remaining will be log 2 by log 4. I'll write over here. Okay. Time taken for 50% divided by 32. What is log 2 by log 4? Log 2 by log 4 is, can I keep log 2 4 as what? Log of 2 square. Same as 2 log 2. So 2 will come in front. So 2 into log 2. I can cancel log 2 and log 2. 32 will come over that side. We'll be getting T 50% as 32 by 2 called 16. Go with option P. Hope you got the logic right. Clear. Yes or no? Yeah, Adi, sure. Jaden. Yeah. Give me some response. Yeah, you're right. People. Thomas, Adi, Muhammad, Humaid. Yeah. Actually, it's a delay for your chat and what I'm getting over here. That's the delay, I think. Sure. Yes. Iba, okay. Yeah, option B, right? 60 minutes. Sure. Okay, I'm continuing. Adi, sure. Now let's go with the next question. It's a good one actually. It's a higher level, I think. I mean, regarding the CBSE, it's just one step above. Let's try. Sure. Yes. Adi. So your question given for a reaction A plus B giving products. Here the question given A plus B giving products. Rate of reaction was doubled when concentration of A was doubled. When the concentration of A and B were double, rate was again double than the order of the reaction with respect to A and B. It's a question. Okay. Sure. Still clear. Sure. So question A plus B giving product. Rate of reaction was double when concentration of A was double. When concentration of A and B was double, rate again double the order of the reaction with respect to A and B. See, A plus B giving, how the rate law will come, how the rate equation will be coming. Rate law equation is R is equal to K into concentration of reactant A raised to some unknown power, calling it as X, into concentration of B raised to some unknown power Y. We have to solve X and Y for order, right? Try. See, here given that rate of reaction was double, that is R become 2R. Rate of reaction doubled means R will become 2R when concentration of A was double. Okay, so K remains same. K is a constant independent of concentration, depends only on, so K will remain same, fine. And concentration of A doubled means I can say A will become 2A all raised to A all raised to X. Nothing mentioned about B means in case number 1 B is a constant. Nothing mentioned about B means B is a constant, so B raised to Y, no issue. Just separate that to A raised to X. We'll be getting like 2R is equal to K. 2A raised to Y, make 2 outside. So I can say 2 raised to X into concentration of A raised to X into concentration of B raised to Y. Actually, K into A raised to X into B raised to Y is same as R. So we'll get like 2R is equal to 2 raised to X into R. R and R cancel. 2 is equal to 2 raised to X means X is equal to 1. Hiba, X is 1, okay. So X is 1. It may be either option A or C. Let's go with Y2, right? Sure. Regarding the Y, we can say what? They're given that if when the concentration of A and B were double, if both A and B are double, when concentration of A and B, both of them are double, rate was again double. It means R become 2R, R become 2R. When concentration of A and B was doubled means A will become 2A, so 2A raised to X, and B will become 2B, so 2B raised to Y, 2B raised to Y. Okay, just separate that. So we'll get like 2R is equal to K into 2A raised to X is same as 2 raised to X into A raised to X, and 2B raised to Y is same as 2 raised to Y into B raised to Y. Okay, that is 2 raised to X into 2 raised to Y, 2 raised to X plus Y, right? So 2R is equal to 2 raised to X into 2 raised to Y will become 2 raised to X plus Y. Remaining is what? K into A raised to X into B raised to Y is R. So R and R get cancelled. So 2 is equal to what? 2 raised to X plus Y. That is 2 is equal to 2 raised means 2 raised to 1. That is 1 is equal to X plus Y. 1 is equal to X plus Y. Here given that X is equal to 1. So what will be Y? Obviously 0, right? So I can say 1 is equal to, here given X is equal to 1. So 1 plus Y, obviously Y will be what? 0. Yeah. Sure, Hiba. So X is 1, Y is equal to 0. Go with option C. C is the right answer. Can I go ahead? Vasant, okay, sure. Vasant, 1, 0. Obviously C, right? Yes. Yeah. Now go with next one. It's a good one, right? I think you didn't see this kind. Let's try. Now next one. Time required for 100% completion. Time required for 100% completion of a zero order reaction. So it's a zero order reaction. For a zero order reaction, yes, clear, Abid, sure. It's a zero order reaction. For a zero order reaction, time or integrated rate equation is given by the formula. Time t is equal to R0 minus R divided by K. Here given that we have to find out time required for 100% completion. Okay, it's 100% completion. We have to find out the time t. Okay, keep t as such. In case of percentage question, R0 will be 100, fine. Minus R. What is meant by R? R is the concentration of the remaining reactant, right? R is the concentration of the remaining reactant. Since what we required is 100% completion. 100% completion means what will be the concentration of the remaining reactant will be 0, right? It will be 0 divided by K. So time will be, I think, here you actually given R0 in terms of A. So go with A. Yeah, sure. No, not infinity, bro. No, Ali. So actually R0 is the initial concentration of reactant, fine. Here given that, I think they taken R0 as A. A is the initial concentration. So go with R0 as A minus, what is meant by R? R is the concentration of the remaining reactant, right? Since 100% completion means concentration of the remaining reactant will be, it's 0, right? So R is 0 divided by K. So A minus 0 by K is same as A by K. A by K means go with option. Yeah, C is the right answer. Clear? Yeah, Hiba, sure. Humaid, Ali, Muhammad, it's not infinite, right? It's A by K. Go with option B. Now going for the next one. What's that? It's a good one. I'm sure you will got mistake over here. Damn sure. Let's see. Question. The rate constant for a reaction A giving B. Rate constant is called K. So K is given to be how much? 0.6 into 10 raised to minus 3 mole per liter per second. I mean mole liter inverse, second inverse. If the concentration of A is 5 molar, okay. If the concentration of A is 5 molar, then concentration of B after 20 minutes is the question. Okay, concentration of B after 20 minutes. Okay, let's try the question. It's a zero order reaction. Since it's a zero order reaction, the integrated rate equation will be time t is equal to R0 minus R divided by K. Okay, fine. No issue. What we required is what will be the concentration of reactant after 20 minutes. Try. Anyway, go with the reaction. Time given to be 20 minutes. So convert in second because it's second. Convert second by multiplying 60. So 20 into 60, which is equal to R0 means initial concentration of reactant given to be 5 molar. It's A given to be 5. Minus R. R is the concentration of the remaining reactant. Let's find out that R first. From R we can think about the question. R is the concentration of the remaining reactant. Keep it R itself divided by K. How much is K? K is 0.6 into 10 raised to minus 3. 0.6 into 10 raised to minus 3 on cross multiply. You will come over this side. So we'll get like 5 minus R is equal to, getting 5 minus R is cross multiplying 20 into 60 into 0.6 into 10 raised to minus 3 will become how much? 20 into 6 will become, I think you will get around 0.78, I guess. Yeah, 0.72, right? 6 into 12, 12, 6 are 70, you will get 0.72. So get like 5 minus concentration of R, 2 into 6 is 12, 12, 6 are 72, we'll get 0.72. That's the value of 5 minus concentration of R. So what will be concentration of R? Minus R going, that will become plus R. So plus R is equal to 5 minus 0.72. 5 minus 0.72 is how much? 4.28, right? But there is no option called 4.28. What we'll do? There is no option 4.28. Any idea? Can tell me please. What we'll do? A giving B, okay. A giving B. Question, read the question once again. Concentration of B after 20 minutes. Any idea? Give me the answer. Regarding the love handle, give me the answers please. What we'll do? Option 4.28 is not here. Any one of you will do what? 4.28 is a concentration of reactant after 20 minutes. Initially, concentration of A was 5. After 20 minutes, here the concentration of the remaining reactant is 4.28, means what will be the concentration of B? Out of 5, currently we have only 4.28 remaining. How much remaining? 0.72. That's 5 minus 4.28 is converted into concentration of reactants B. So it's actually 5 minus 4.28 called 0.72 is the answer. Question is not actually, not divided by 20, man. It's actually what we required is concentration of B after 20. B is the product, bro. It's a product, right? It's a product. What we required is amount of product after how much? 20 minutes. Initially find out the concentration of the remaining reactant. Initially was contained 5 molar, okay, but after 20, remaining concentration is 4.2, means I can say out of 5, currently we have only 4.2, means 5 minus 4.2 called 0.72 convert product. So it's, yeah, Dania, 4.72 option C, sure. Dania Abdullah, sure. Can I go ahead? Yes or no, please? I don't know how many people are here in live right now. How many people are there, sir? How many people?
I think almost 80.
80 people are, yeah, so I mean almost all actually here, right? 80 is not our strength, right? Yeah. Respond, please. Hiba, Dania, Rehan. Can I go get? Sure. Next one, please. It's a good one. Question. The rate of a gaseous reaction is given by the expression, rate is given by the expression R is equal to K into concentration of A into concentration of B. If the volume of reaction vessel is reduced to 1/4 of the initial volume, then the reaction rate related to original rate will be. Okay. Question given that the rate of a reaction is given by the expression R is equal to K into concentration of A into concentration of B. If the volume of reaction vessel reduced it to 1/4 of the initial volume, then the reaction rate related to original rate will be. See, actually, yeah, Falak. See, actually, concentration is, volume is 1/4 means, what about the concentration? C square bracket is called, it's concentration, right? That concentration will be given in terms of molarity given by the formula number of moles divided by volume. When volume is reduced to 1/4 means V will become V/4 means I can say concentration will become 4 times. So rate will become 4 into 4 called 16, or I can say rate is increased by 16 times. Go with option D. Here instead concentration volume, but I know concentration is molarity in terms of it's in terms of molarity, that's number of moles by volume. When volume is reduced to 1/4 means constant will become 4 times, so it's 4 into 4 called 16. Option D is right answer. Hope you are fine. Clear? Now going for the, yeah, it's the most hot question for you today. Let's try. It's actually a neat question. Let's try. Question given that 2O3 giving 3O2, 2O3 giving 3O2, proceed as follows. O3, it's actually a reversible arrow, okay? It's actually a reversible arrow. O3 reversibly giving O2 plus O, given it's a fast reaction, okay? It's a fast reaction. Then second one, given that O plus O3 reversibly giving 2O2 is a slow reaction, the rate law expression would be, it's a complex reaction because taken place in 2 steps. In a complex reaction, rate determined step will be the slowest step. And one more thing, molecularity of the slowest step will be same as what? Order of the reaction. For example, it's a complex reaction, take place in more than 1 step, okay? First step is the fast one, second step is the slowest one, go with the rate law. Since rate law depends upon slowest step. And one more thing I know, Jaden, no, yes, it's B. I got the answer, man. Sure, Jaden, it's option B. So O plus O3 reversibly to O2 slowest step. I know rate determined will be slowest step. And one more thing, molecularity of the slowest step will be same as order of the overall reaction. So it's the slowest step. From here we can say that rate law will be, from here I can say rate law will be R is equal to same as the molecularity of the slowest step. So K into, here molecularity is 1 and 1. So we'll be getting like R is equal to K into concentration of A in O into concentration O3. But unfortunately option is not there. Options are all in terms of O3, either O3 only or O3 in terms of O2. So we'll do what? We can do one thing, right? It's a first one is a reversible reaction, right? It's a reversible reaction. This reversible reaction will achieve finally, it's a constant called equilibrium constant given by the formula. It's a reversible. The problem is we got rate law, okay? It's a complex reaction, having two step, and I know the rate law of a complex that depends only on slower step. Here the slower step is second step, and its molecularity will be same as order. Okay, so R is equal to K into concentration of O into concentration of O3. Fine. See, one more thing. The problem is option does not contain these laws. So let's rethink again. It's a reverse. So we can do like this. First one is a reversible reaction. You have to make option in terms of O3 and O2, or either O3, but here contain O also. So reframe this O. Let's see. First option, first one is a fast, it's a reversible reaction. Finally achieve equilibrium. So we'll be having equilibrium constant Kc will be given by the formula what? Equilibrium constant Kc is equal to concentration of O2 into concentration of O, nothing that you know, C A raised to A plus B raised to B, reversibly giving Cc plus D. The equilibrium constant will be Kc is equal to C raised to C into D raised to D by A raised to A into, same formula I'm using here, product by reactant, product are concentration of O2 into concentration of O divided by concentration of O3. From here, create a formula for concentration of O, substitute over here. From here, I can say what will be concentration of O. From here, we can say concentration of O is equal to O3 will come this side, Kc into concentration of O3, O2 will come down, so divided by O2. Put that value over here. Put that value over here. So we'll get R is equal to K into concentration of O3 same as Kc into concentration of O3 divided by concentration of O2 into concentration of O3. So we'll get like R, K is a constant, right? Constant. Kc is equilibrium constant, again constant. So constant to constant will become again a constant. I'm calling it as new constant, K dash or some constant, into O3 will become O3 square. O2 moving up will become O2 raised to minus 1. Yes, it is what? Option B. Jaden. I don't know how much you go this one. Correct. K3 into, K into a constant into O3 is going to O2 is minus 1. Sure. Yeah, Abid. Add reaction will not work here, bro. It will not get simple one, right? Yeah, sure. Jaden, Joby. So that's all regarding the question. Going for next one. Yeah, Arrhenius equation can be represented graphically as follows. Arrhenius equation can be represented graphically as follows. It's a graph between L and K and 1 by 2. What is Arrhenius equation? Arrhenius equation is given by the formula K is equal to A into concentration of, R is equal to K into E raised to E minus EA by RT, where K is the rate constant, A is called as Arrhenius constant or Arrhenius factor, E is exponential function, EA called activation energy, R is called universal gas constant, T is the temperature. Okay. So create an equation in terms of L and K and 1 by T, go for a straight line. Since it's a Arrhenius equation, you can apply a natural log on both sides. So getting what? Ln of K is equal to Ln of A into E raised to minus EA by RT. It is same as log A into B. Log A into B is log A plus log B. Getting what? Ln of K is equal to Ln of A minus Ln of E raised to minus EA by RT. Ln of E raised to minus EA by, it's plus actually, log A plus log B, so Ln of A plus Ln of E raised to minus EA by RT. It's same as log X raised to, power will come in front, will get like what? Ln of K is equal to Ln of A, power will be coming in front, so minus E by RT into Ln of E. Ln of E is 1, so we'll be getting what? Ln of K is equal to Ln of A minus EA by RT, rearrange to get Y is equal to mx plus C. Ln of K is equal to Ln of A minus EA by RT, same as minus EA by RT plus Ln A. Now it is of the pattern Y is equal to mx plus C. Y axis contains Ln of K, okay. X axis contains 1 by T, okay, 1 by T, fine. So from here what we can say? Slope M is equal to minus EA by R, Y is equal to mx plus C. Slope M is equal to minus EA by R, and the y-intercept C is same as what? Ln of A. So slope, intercept and slope. Intercept is Ln of A and slope is minus EA by R. Go with option C. Sure. Hope you are fine. Yeah. Okay, so there is one more question for you right now. Hope we got it. The last question, it is that a biochemical reaction was carried out in the absence of enzyme, and the rate of reaction was found to be, actually rate means unit should be what? Mole per liter per minute. Okay, it's rate, so unit should be mole per liter per minute. Okay, fine. Anyway, a biochemical reaction was carried out in absence of enzyme. Rate of reaction was found to be 10 raised to minus 6. If the same reaction is carried out in the presence of enzyme, then the activation energy EA for the reaction will be, what will be? See, what a catalyst will do. A catalyst will do a shortcut path having lower activation. So your question given that a biochemical reaction was carried out in absence of enzyme. Okay, in absence of enzyme, rate of reaction was found to be 10 raised to minus 6. The same reaction is now carried out in presence of enzyme. Enzyme will provide a shortcut path having lower activation. Means you can say with the presence of catalyst, the activation energy EA will become what? It will become biochemical reaction found absence of enzyme. Rate is 10 raised to minus 6. If same reaction is now carried on person of enzyme, activation energy EA will be, it will become what? Lower, right? Because activation will provide, or catalyst will provide a shortcut path having lower activation. You can go with option C. Hope you are fine. Hope you got something right. Can you have response, please? Is it okay? How activate, how it will provide means, imagine an example. Okay, how catalyst will provide a shortcut path means, imagine an example. Okay, suppose we have a class having 50 students. I've taken an exam out of 10 mark. Actually, pass mark was 5. Suppose 20 people are pass, remaining 30 people is fail. Why 30 people fail? Because remaining 30 people does not have that pass mark 5, right? How can I increase the number of person which is passed? Repeat question once again. Suppose we have an exam or conducting a test on a class of 50 people. A test is out of 10 mark. The pass mark was 5. 20 people was passed and 30 people failed. I mean, remaining 30 people does not have that pass mark 5. So I can increase the percentage of people passed by reducing the pass mark. Reducing that 5 into maybe like 4, 3, not into 1 man, like 4, 3, 2, right? So by reducing the pass mark, I can say more people. That's the same thing activation, and I mean the catalyst will be doing. Catalyst, yeah, sure, Mohammed. Catalyst will provide a shortcut path having lower activation. So that is the same thing. Hope you got something. Now we can switch discussion into haloalkanes. Mahesa will join within 2 minutes. Okay. So can I wind up now? Sean, Mohammed, Hannah, Rehan, Ibnat. Okay, you can take a small break. We'll join back soon. Thank you.
Okay, good evening students. Can you hear me? All of you can hear me, right? Please respond. Yes? Are you there? Okay, so today we are going to discuss about halogen compounds. You know, it's a first chapter, organic chemistry. It is an easy chapter compared to all other organic. So today we will discuss about main important, very important 12 questions from that chapter. Okay, that will cover important area, the related concept I will explain here. So if you want, you can note down on the spot. But you know, actually it is very important questions. It is going to come in the board exam. Okay, so we are going to start it. First question. Can you read it? Yes, the question is, which of the following belongs to the class of alkyl halides? Option A, CH2 double bond CHCl. You can read it now. Option B, CH2CH single bond CH2 CH2 CH2Cl. Option C, there is a halogen after double bond. Option D, like that. What's your answer? Anybody got the answer? Tell me. This is a last year board exam question. Anybody tell me the answer fast? Yes, I want the answer from your side. Anybody? Okay, let me discuss. Okay. Option A, how it will be. So we'll discuss. Okay, Miva, right answer, very good. Yes, don't worry, Sean. You will be delivering soon. Okay, yeah. So we are doing this now. Wait, very good. Option B is the answer. How we can do? Just wait. Okay, we know that alkyl halides, halogen compounds are classified into different category. Compounds containing, we can say sp2, compounds containing sp3CX bond, sp3CX bond, and compounds containing sp2CX bond. In sp3CX bond you have alkyl halide. Yes, alkyl halide. Then you have allylic halide, then you have benzylic halide. Okay, in sp2CX bond you have vinylic, then aryl, right? These are the conditions. Now here in alkyl halide we know that, so halogen is connected to a single bonded carbon. We know halogen is connected to a single bonded carbon. That is 100% sure. Halogen is connected to a single bonded carbon. Here you can see, you can avoid this here because here halogen is connected to a double bonded carbon. This is not alkyl halide. Here halogen is connected to a double bonded carbon. So here all, in this case also, halogen is connected to a single bonded carbon. But here you can see, in allylic halide, this is allylic halide, we can say halogen is connected to a single bonded carbon. Halogen is connected to a single bonded carbon next to the double bond. So we can consider this is an allylic halide. This is not alkyl halide. In allylic halide, halogen is connected to a single bonded carbon next to the double bond. In benzylic halide, you can see halogen is connected to a single bonded carbon next to the benzene ring. This is called the benzylic halide. Here, halogen is connected to a single bonded carbon next to the benzene ring. So this is allylic halide, we can avoid it. This is also similar type as allylic halide, we can avoid it because halogen is connected to a single bonded carbon next to the triple bond. Okay, so here halogen is connected to a single bonded carbon, but double bond is far away. There is no, actually here halogen is connected to a single bonded carbon next to the double bond. Here halogen is connected to a single bonded carbon next to the triple bond. You can see there is a chance of resonance here. In both cases resonance are possible. So this bond will develop partial double bond and everything. So we can go for this is the best option. Okay, So the option B is the correct answer. All of you got it? Yes or no? So we are moving to the next question, right? Okay. So we are moving to the next question now. So now next question is that, can you read the question? Which of the following isomer of pentane formula is given? Yes, C5H12 will give 3 isomeric monochlorides on photochemical chlorination. Yes. What is this photochemical chlorination? You studied already. Yeah, you studied already in 12th standard. Photochemical chlorination will give you so many products. It will give monochlorinated product. It will give dichloro product, polychloro product, etc. etc. So this is a simple logic over here. This is the alkane. Treating it with the chlorine in presence of UV, you will get RCl. This is a monochloro product. In monochloro product, we will remove hydrogen and we will replace it by chlorine, right? Yes, we will remove hydrogen and we will replace it by chlorine. Depending upon the nature of hydrogen, there are so many types of products. We can see now in the first compound, we can see the first compound. We are replacing this hydrogen by chlorine. Yes, we are replacing this hydrogen by chlorine. Or we are replacing this hydrogen by chlorine. Or we are replacing this hydrogen by chlorine. Or by this. In all these cases, you can see, you will get similar type of product. So compound A will give single monochloro product. We can see in board exam, sometimes they are asking, which of the following will give single monochloro product upon chlorination. This is chlorination. This is alkane. On treating with the chlorine in presence of UV, we will remove hydrogen. Yes, we are removing hydrogen using screwdriver and we are fitting chlorine over there. That is equal to monochloro product. So in monochloro product, we will get license to remove one hydrogen and replace it by chlorine, right? That's it. So here, this product, this will give single monochloro product. You can say here, the monochloro product upon chlorine in presence of UV, you will get a product like that. CH3, C, CH3, CH3, then CH2, Cl. Here, if I am keeping chlorine here, or here, or here, or here, no matter, the IUPAC name of the compound will be same. So this is the one which gives single monochloro product, right? Now they are asking which isomer of pentane will give 3 isomeric monochloro product. See, how many hydrogen atom here? You can see here, if I am keeping chlorine here, you will get one monochloro product. You can replace, you can replace hydrogen by chlorine here. Yes, you will get another monochloro product. You can replace this hydrogen by chlorine here. Yes, you will get another monochloro product. Or you can replace hydrogen by this chlorine here. You will get another monochloro product. So this isomer will give you 4 monochloro product. 4 monochloro product. Okay. They are asking 3. How you got 4? Here you will get 1 chlorine. Here you can replace hydrogen by 1 chlorine. Here you can replace hydrogen by 1 chlorine. Here you can replace hydrogen by 1 chlorine. Here and here. Here and here you can see here and here. It will be same effect. Okay. You can see same effect. So this will give 4 monochloro product. Now coming back to this. Yes, I am going to explain now. See. This is a compound you have. Yes, this compound you have. Here you can replace by chlorine. Yes, here you can replace by chlorine. You will get a compound like this. Yes, see, this is the one. Here you will get a compound like that. This is CH3, CH2, CH2, CH2. Then 1, 2, 3, 4. Then 5, 5th one we can replace this one by chlorine. Yes, one monochloro product. Another one possible here, it is that CH3, CH2, CH2. Then CH, Cl, CH3, second monochloro product. And another one possible here in the middle we can keep. So CH3, CH2, CH, Cl, CH2, CH3. 3 monochloro products are possible. See now here, whenever we are replacing this hydrogen, that will be the repetition of this one. Whenever we are replacing this hydrogen, that will be the repetition of this one. So the option B will give 3 isomeric monochloro product. Okay, remember that. So option B is giving 3 isomeric monochloro product upon chlorination. Got it? So all of you got it? I hope so. Is it okay? I can move to the next question, right? Any doubt? Students, you can respond here. I can read your message. Are you okay with it? Yes. I'm moving to the next question now, right? Yes. So, next one we are talking. Yes. So, can you read the question now? Assertion reasoning question. Okay, we have assertion reason question now. Yes, listen. Yes, listen now. Very good. You need repetition? Yes. Do you want repetition of that question? Okay, clear. So listen now. Now assertion we are talking. You can read the question now. Boiling points of alkyl halides decreases in the order alkyl iodide, alkyl bromide, alkyl chloride, alkyl fluoride. We studied before. Boiling points depends upon molar mass. Boiling points increases with the increase in molar mass. We know that. Okay, increase in molar mass. Or increase in van der Waals forces. Increase in van der Waals forces. Van der Waals forces, right? Increase in van der Waals forces. Increase in van der Waals forces. We know that. Okay. So when boiling point increases with increasing molar mass and increasing van der Waals forces. Here we know that iodide has higher molar mass than bromide, then chloride, then fluoride. So boiling points of alkyl halides decreases in the order. Yes, this is correct. Assertion is correct. Highest boiling point is for iodide, then bromide, then chloride, then fluoride. Assertion correct. No doubt about it. Assertion correct. What about the reason? Van der Waals forces decreases with the increase in size of halogen atom. Repeating, van der Waals forces decreases with the increase in size of halogen atom. See now, we have halogens like fluorine, chlorine, bromine, iodine. On moving down the group, what happened to size of halogen atom? Size of halogen atom increases upon moving down the group, right? Fluorine, chlorine, bromine, iodine. Size of halogen atom increases upon moving down the group. No doubt. So on moving down the group, size increases, also molar mass also increases. So when molar mass increases, van der Waals force also increases. You know, you studied van der Waals forces in lower sessions. Attractive force between molecules, general attractive force. You know, there are so many types of van der Waals forces. London forces, dipole attraction. So these all forces increases with the increase in molar mass. So this fact is wrong. You can say on increasing size of the halogen atom, molar mass increases, van der Waals force increases. So reason van der Waals force decreases with increasing size of halogen atom is wrong. So assertion correct, reason wrong. So this is the answer. Assertion is true, reason is false. Okay, I think all of you got it. So we are moving to the next question, right? Are you okay with it? Please respond. Okay, good. So we are moving to do now next one, right? Yes. So next one we are talking about, in the following reaction, name the process if only B is the product obtained. See students, you studied about so many inversion of configuration, or retention of configuration, racemization, etc. in nucleophilic substitution reaction. So we know that what is inversion, what is retention, what is racemization. Okay, so this is the reactant. We have a reactant over here. Yes, we have a reactant over here. This is the reactant. Yes, this is the reactant. This reactant, on treating it with Y, you can see this X is replaced by Y. X here is replaced by Y. You will get a product. And here in this reaction, when it is treating it with Y, X is replaced by, you will get a product B. How to decide inversion and how to decide retention? We studied before in the class, we explained. See, so if the product is just like a object, we can say that this is a retention of configuration. Here product is, you can say this is the product, here this product. The arrangement over here and arrangement over here is same. You can say the orientation of C2H5, HCH3 here, and X and Y arrangement is same. So we can call this process involves a retention of configuration. If product A will give you a retention of configuration, we can say it is a retention, right? Okay. Now we can say product B. Product B is exactly mirror image, is just like a mirror image of this. The product B is just like a mirror image of this. This is the reactant. Product B is just like a mirror image of this. Only the difference is that X is replaced by Y. This one involves inversion of configuration. Okay. So in the reaction, if name the process if B is the product obtained. If B is the product obtained, the answer is inversion of configuration. And if A and B both are obtained, can you tell me what will be the answer if A and B both are obtained? This is retention, this is inversion. If product A and B both are obtained, we call it as what? A racemization. That also you have to check. This is a reader diagram. They can ask questions based on that particular diagram. This is also a previous board exam question. Okay, go through it. So our answer is, if product B is the answer, inversion of configuration. If product A is the answer, a retention of configuration. If both are present, you can say racemization. Okay, so we are moving to the next point. I hope all of you are okay with it, right? Now see. Yes, listen. Listen now. So we are moving to do next one. A dextrorotatory optically active alkyl halide undergoes hydrolysis by SN2 mechanism. The resulting alcohol is. Anybody can tell me the answer? Anybody? What's the answer here? A dextrorotatory optically active alkyl halide undergo hydrolysis by SN2 mechanism. The resulting alcohol is. We studied like that. SN2 involves inversion of configuration. SN1 involves a racemization, right? Okay. So here the dextrorotatory, we can say the dextrorotatory compound is here. Suppose you have a dextrorotatory reactant. For example, I have a compound like that. This is a chiral carbon atom. We have different groups over here. This is equal to CH3. This is equal to Br. This is equal to CH2CH3. This is equal to H. Upon hydrolysis, for example, this is for roughly I am telling, upon hydrolysis means reaction with OH minus. Bromine is replaced by OH, right? Bromine is replaced by OH. We studied before, in SN2 reaction, the product is just like a mirror image. We know that product is just like a mirror image. It involves inversion. We studied that SN2 involves inversion. Product is just like a mirror image. We studied before. So the product will be just like a mirror image. The mirror image of this will be coming this way. This is the product obtained, CH3. And here this will be H. And here this will be CH2, CH3. So the mirror image will be like that. This is a mirror image obtained over there, right? Yes. So this is the reactant. This is the product. In SN2 we know that product is just like a mirror image. Okay? Yes. So how? Now the question is whether it is dextrorotatory or whether it is levorotatory. That's the problem. Or it is dextro or levo together. Wait, we will discuss. Okay? There is no relation between configuration and optical rotation. That's an important point. Everyone should remember this. Okay? Most of them have wrong concept like that. So, sir, dextrorotatory is converted to levorotatory during inversion. Dextro convert to dextro during retention. It is not like that. So you have to remember this important point here. We can say this is equal to, suppose this is dextrorotatory, this is inversion. The product is just like a mirror image. is just like inverted product, no doubt. But you can see the dextrorotatory can become dextrorotatory product. Dextrorotatory can become levorotatory product. There is no relation between inversion of configuration and specific rotation. So our answer will be the product can be maybe dextro or levorotatory. Remember, repeating it again. Repeating, this is a wrong concept for you people. This is very important for you. I'm telling it again. So dextrorotatory optically active alkyl halide undergo hydrolysis by SN2 mechanism. Yes, it will undergo inversion. No doubt about it. SN2 involves inversion. No doubt. But it may be dextrorotatory or levorotatory product. That is the answer. Okay, so there is no relation between optical rotation and configuration. Got it? So the answer is what? Maybe dextro or levorotatory. Got it? Are you okay, students? You got it? So we are moving to the next question. Okay. See now. I hope all of you got last question, right? Yes, you can comment. Okay, we are moving to the next one, right? So, consider the following compounds. These are the three compounds you have. Number 1, number 2, number 3. The correct order of reactivity towards SN2 reaction. Anybody can tell me the answer? Is an easy question. You can manage. Please tell me the answer fast. Yes, Hiba, tell me the answer fast. Yes. Sean, what's the answer here? Yeah, we know that order of reactivity of SN2. What's the order of reactivity of SN2? We know that reactivity of SN2. This is the theory you have to remember. Reactivity of SN2 inversely proportional to steric effect. Okay, reactivity of SN2 inversely proportional to steric effect. The order of reactivity of SN2 is methyl top, then primary, then secondary, then tertiary. This is the order of reactivity of SN2 reaction, right? Order of reactivity of SN2 reaction is like that. Reactivity of SN2 is inversely proportional to steric effect. The smaller halide will be more reactive in SN2. The bigger one, the gigantic one or fatty one will be less reactive towards SN2 because it depends upon steric effect we studied already. So now you have to classify them into this is equal to then you can say vinylic, then we can say aryl. This is the order of reactivity of SN2. Methyl, primary, secondary, tertiary, vinylic, aryl. This is the order of reactivity of SN2. Compare this and here you will get the answer. See, we are discussing the answer now. So this is number 1, number 2, number 3. The correct order of reactivity towards SN2. Okay. This is equal to primary. Second one we can call it as primary because it contains CH2Cl. CH2Cl is equal to primary, right? The first one we can call it as secondary because it is secondary because halogen is connected to a carbon which is connected to two other carbon. This is secondary halide. Here halogen is connected to a carbon which is connected to two other carbon. So this is a secondary halide, right? Secondary halide. This is primary. What about this? This is coming under aryl halide. Okay, this is coming under aryl halide. So we have primary, we have secondary, and we have aryl halide. So what is the order of reactivity here? We know that, yes, the primary is more reactive here, then secondary, then aryl is coming. So the second one will be the most reactive, then first one, then third one. So the answer will be what? Second more reactive, then first one, then third one. Answer is C. Okay, I think all of you got it, right? This is an easy question from year level, right? Okay, so we are moving to the next question. Yes, so now next question we are talking. This is also related to CBSE normal question. This is also, it came in last year board exam question. Okay. See, I want the answer from your side. What is the answer for this? Which of the following compounds more reactive towards SN1 reaction? See, you have to remember what is the order of reactivity of SN1. Reactivity of SN1 depends upon what? I am just briefly explaining just the order of reactivity. So listen. Order of reactivity of SN1. We know that reactivity of SN1, okay, reactivity of SN1 is directly proportional to stability of carbocation. Stability of carbocation. This is the important thing you should remember. Okay, reactivity of SN1 is directly proportional to stability of carbocation. Yes. Stability of carbocation depends upon so many factors. We know that it depends upon hyperconjugation effect. We studied in 11th standard. It depends upon resonance effect. That also we studied. So what is the order of stability of carbocation? Which order you have to remember? Yes. You have to remember this order. Benzylic. Benzylic is highly reactive. Then allylic. 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 Then tertiary. Then secondary. Then primary. Then we can say vinylic. Methyl. We can say methyl. Methyl. Or methyl we can leave for the being time. Then vinylic. 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 Then aryl. So this is the order of reactivity of SN1. This is same as order of stability of carbocation. This is the order of reactivity of SN1. Reactivity of SN1 is same as reactivity of SN1 is same as stability of carbocation. See now, what is benzylic? Yes, in benzylic halide we can say halogen is connected to a single bond carbon next to the benzene ring. In allylic we can say halogen is connected to a single bond carbon next to the double bond. That is allylic. Okay, here halogen is connected to a single bond carbon next to the benzene ring. Here halogen is connected to a single bond carbon next to the double bond. And tertiary we know that there is other than halogen 3 other lines other than halogen. Okay, halogen is connected to a carbon which is connected to 3 other carbon. This is secondary. We can say this is equal to secondary. Here halogen is connected to a carbon which is connected to 2 other carbon. This is primary. This is primary. This is vinylic. We can say vinylic halogen is connected directly to the double bond. This is aryl. Halogen is connected directly to the benzene ring. This is the order of reactivity. We can say this is the order of reactivity of SN1. Right? This order of reactivity. Now coming back to this question. See the question. What is the order? This is coming under allylic. Yes, this is coming under allylic. Why allylic? Tell me fast. Here halogen is connected to a single bond carbon next to the double bond. Same as this. Here you can see allylic over here. Here halogen is connected to a single bond carbon next to the double bond. So this one is allylic. This is benzylic. We can say this is benzylic. Yes, benzylic. This is also benzylic. I will write that thing properly. Listen, what is the expansion of that? B I am expanding. The compound B will be like that. This is equal to compound B. Yes, this is compound B. CH2Br. This is compound B option. And this is a compound C option I am writing. Compound C option. We have a benzene ring. Yes, we have a benzene ring. And we have CH. We have CH. And we have Br. We have another benzene ring. This is the expansion of compound C, right? And I am expanding the compound D. This is compound D expanding here. Compound D expanded version is like that. This is the benzene ring. We have CH. Yes, we have CH, Br, CH3. See now. We are discussing these all compounds now. This is equal to, we can say, this is equal to, yes, this is equal to benzylic primary. This is benzylic primary. This is equal to benzylic secondary. This is benzylic secondary. So what is the order of reactivity among different benzyl halide? Among different benzyl halide, you have to remember this. Different benzyl halide order of reactivity is tertiary, secondary, primary. This is the order of reactivity of different benzyl halide. These are all benzyl halide, B, C and D. B, C and D, all are benzyl halide. This is benzylic because halogen is connected to a single bond next to the benzene ring. Here also halogen is connected to a this carbon. Actually halogen is connected here. This is inside the bracket. So halogen is connected here. This is the B option. C. Okay. So here we can say here we have a confusion with these two secondary. This is secondary. This is also secondary. Here you have two benzene ring. Here you have methyl. See one short important point regarding benzyl halide. In benzyl halide, when number of benzene ring increases, the resonating structure number will increase. Repeating, in benzyl halide, when number of benzene ring increases, the number of resonating structures also will increase. So, more number benzene ring, more resonating structure, more stable carbocation. So, out of these two secondary, this will have more stable carbocation because it has more number of resonating structure. Okay, so that is the reason. So our option is S, which of the following more reactive towards SN1? Our option is C because that is benzylic and that is secondary benzylic and it has more number of resonating structure because of more number of benzene ring next to the single bonded carbon. That's the answer. I think all of you got it. Can you tell me which is the most reactive benzyl halide? The most reactive benzyl halide towards SN1. Yes, the most reactive benzyl halide towards SN1. We can say there will be 3 benzene ring here. It will be a tertiary halide with the 3 benzene ring here. This is the most reactive compound in SN1 reaction. This is the most reactive compound in the SN1 reaction is equal to tertiary benzyl because this compound is stabilized by resonance. There are more number of benzene ring over here and this more number benzene ring will bring more number of resonating structure and that is stabilized by resonance and this is the most reactive halide among all halides towards SN1. Note down, okay? Completed? Yes, students. So we are moving to the next question. Is it okay? Respond fast. Yes, we are moving to do now, right? Yes, listen. See now. The next question, okay? So we are moving to do the next one. Okay, listen. Yes. Assertion, reason question we are discussing. Most of the students are making mistake in assertion, reason. So you should know the subject well, you should know the concept well, then only you can crack assertion, reason properly. Okay, see we will do. Nucleophilic substitution of iodoethane is easier than chloroethane. Yes, nucleophilic substitution of iodoethane is easier than chloroethane. Second one, bond energy of CCl bond is less than Ci bond. Bond energy of CCl bond is less than Ci bond. Anybody can tell me the answer fast? It's an easy question. You already studied. Tell me fast. Waiting for your answer. Yes, listen. Anybody? Humaid, why are you laughing? Tell me the answer fast. Yes. Okay, we will see. Some of them already told the answer. Good, very good. So we will see. Okay, Abid, we'll see. Assertion, nucleophilic substitution of iodoethane is easier than chloroethane. We know that. What is nucleophilic substitution reaction? Whether it is in SN1 or SN2, what is the order of reactivity of different halogen compounds? Yes. In SN1 or SN2, the order of reactivity of different halogen compound is like that: RCl, RBr, Ri, Rbr, Rcl, then Rf. This is the order of reactivity of halogen compounds in SN1, in SN2, in beta elimination, in reaction with the metals, Remember these all, students. This is a key point for you. Just note down. This is the order of reactivity of halogen compounds in SN1 also, in SN2 also, in elimination reaction also, in reaction with the metals also, right? So this is the order of reactivity. What is the reason behind it? So easy now. Here carbon iodine bond you can see, carbon iodine bond. Here you can see carbon bromine bond. Here you can see carbon chlorine bond. Here you can see carbon fluorine bond. See now which bond is weaker bond? Yes, carbon iodine bond is weaker bond. Why? Yes, carbon is a small guy. Iodine is gigantic. They are making a bond in between each other. It's very hard. The main problem is size difference. So the carbon iodine bond is weaker bond because the size difference is more. So the bond dissociation enthalpy is very less. So we can say nucleophilic substitution of iodoethane is easier than chloroethane. Yes, that's correct. No doubt about it. Because carbon iodine bond is weaker than carbon bromine bond as well as carbon chlorine bond as well as carbon fluorine bond. Because carbon iodine bond is weaker bond, it has very less bond dissociation enthalpy. Bond dissociation enthalpy means energy required to break one mole of that bond is very, very less. Energy required to break the bond is very less. Think like that carbon got married with iodine, and after the marriage the problem is size difference. So it's very hard to adjust. So carbon iodine bond is so weaker bond. Think like that. Okay. Yeah. So here we can say now nucleophilic substitution of iodoethane is easier than chloroethane. Correct. So bond energy of CCl bond is less than Ca bond. That is wrong. So assertion correct. Reason false. So option C. Okay. Option C is your answer. Got it? So we are moving to the next question. I hope all of you got it, right? Yes. Any doubt? Yes, we are moving to the next question, right? Good. So the next one, right? Yes. What is the reaction here? This reaction is a familiar question in board exam. You can see. Sorry. So this is a familiar question in the board exam. You can see. Every time they are asking. This is a part from Grignard's reagent part. So let me explain this concept. We studied one rule in organic chemistry. What is the rule over here? Listen. Okay. So this is a reaction we studied. We have a halogen compound. Yes. We are treating it with a magnesium in dry ether. Yes, magnesium in dry ether. Yes, magnesium in dry ether. You will get RMgX. This is called the Grignard's reagent. We studied. This is a familiar compound you may be knowing. So this is called the Grignard's reagent. So Rx on treating it with Mg in dry ether, you will get RMgX. So this is a bond between carbon and halogen bond is here, carbon and halogen bond. So magnesium will come in between this. This is an organometallic compound that is equal to Grignard's reagent. Yes. Then Grignard's reagent on treating it with. Okay. On treating it with any protic solvent. What do you mean by protic solvent? Solvent containing H plus or solvent which can produce H plus. So it can be water or it can be H plus or it can be even ROH. Okay, even ROH, alcohol. It is possible even with ROH. So remember you have to learn that thing. Okay, so that means Grignard's reagent on treating it with any protic solvent. Protic solvent means the solvent which can produce H plus, solvent which can generate H plus. Okay, so H2O, protic solvent, acid, protic solvent, alcohol, protic solvent. So RMgX on treating it with these all. Immediately the MgX is replaced by H. This is the reaction we studied in 12th standard. Now coming back to that information here. See now. This is cyclohexane ring with bromine. Treating it with Mg in dry ether. You will get X. And H2O, Y. The compound Y is. Anybody can tell me the answer? Easy question now. Just compare and do it. What's your answer? Tell me. Which is your answer? Yes. Tell me the answer fast. Yes, very good. So here we will get the answer this way. This is the answer. We can say bromine here. Yes, bromine. With Mg in dry ether you will get. With Mg in dry ether you will get cyclohexane ring with MgBr. MgBr. And with the H2O, the MgBr is replaced by H. You will get cyclohexane. This MgBr is replaced by H. So we are not showing H over there because we are representing in bond line notation. In bond line notation, we won't mention H over there. So the answer is this is equal to cyclohexyl bromide. Treating it with Mg in dry ether, you will get an Grignard's reagent. With H2O, you will get cyclohexane. So your answer is C. Okay, the answer is C. Just go for it. So the answer is C. Very good. So we are moving to the next question now, right? Okay. Assertion reason question again. Remember students, whenever you are doing assertion reason, there is a chance of making mistake. Read the concept clearly and do it. See, now we are going to do now. Assertion reason question. Chlorobenzene is less reactive towards nucleophilic substitution reaction. That's the first assertion. Chlorobenzene is less reactive towards nucleophilic substitution reaction. You know why? You studied already. That's an important area in CBSE exam. They are targeting this area every time. You can see past papers. They are asking questions from this. So chlorobenzene is less reactive towards nucleophilic substitution reaction. Yes or no? Yes, we know that chlorobenzene is less reactive towards nucleophilic substitution reaction. Yes, correct. May know the reason, which are the reasons? Yes, capsule form, I will tell you there are 4 reasons why chlorobenzene is less reactive. Number 1, chlorobenzene carbon-chlorine bond has partial double bond nature. Carbon-chlorine bond has partial double bond nature due to resonance. That's one reason. CCl bond in aryl halide or chlorobenzene has partial double bond nature due to resonance. That guy is engaging in resonance, and because of that, this carbon-chlorine bond has partial double bond over there. That's the number 1 reason. Number 2 reason, it has sp2-CX bond. sp2-CX bond is less polar and less reactive. sp2-CX bond is less polar and less reactive. Third point, it has unstable carbocation. It has unstable carbocation. So you can see this aryl carbocation is unstable. So that's the reason it is less reactive. Fourth one, it has high steric effect. High steric effect. Okay, high steric effect. What is high steric effect? Yes, this is chlorobenzene. This is chlorobenzene. We can say this is the, I can compare this guy as small neck and big body over there, big body. So this is bulky body is preventing the nucleophilic attack over there. So nucleophile wants to attack here. So we can say nucleophile wants to come and attack here. The body is preventing the attack. The bulky body is preventing the attack. So we can say it has high steric effect. So these are the 4 reasons why chlorobenzene is less reactive towards nucleophilic substitution reaction. So that's an important point in board exam. They may ask questions from that area. It's very, very important, students. Keep in mind this is very important. So chlorobenzene is less reactive towards nucleophilic substitution. Correct. Assertion correct. Reason we are talking. Reason, these are the reasons. CCl bond has partial double bond. sp2-CX bond is less polar, unstable carbocation, high steric effect. These are the reasons. No such reason given over there. So reason and assertion, there is no relation. We'll see whether that point is correct or not. Yes. Nitro group in chlorobenzene increases the reactivity towards nucleophilic substitution reaction. Tell me what's your opinion? Yes, we studied before. In 12th standard, we studied this one. Presence of electron withdrawing group. Which are the electron withdrawing group? NO2 is electron withdrawing. CN is electron withdrawing. Halogen is electron withdrawing. So presence of electron withdrawing groups at ortho and para position of chlorobenzene increases the reactivity of nucleophilic substitution reaction. we studied, they increases the intermediate carbanion generated, increases the stability of intermediate ion generated. That intermediate ion we call it as carbanion, we explained in the class. So yes, it is correct, nitro group in chlorobenzene increases the reactivity towards nucleophilic substitution. Nitro group is electron withdrawing group. Electron withdrawing groups are also called groups with plus I effect. Yes, they increases the reactivity of nucleophilic substitution reaction of aryl halides. It's correct. So reason is correct. Okay, it will increase the reactivity by increasing the stability of intermediate ion generated. That's the reason we explained in the class. So just remember, this is very, very important. So nitro group in chlorobenzene increases the reactivity towards nucleophilic substitution. Yes, correct. So assertion, reason are correct, but reason is not the correct explanation. So option B. We can go for option B because both assertion, reason are true. Reason is not the correct explanation of A. So that's the answer for this. Hope all of you got it. So we are moving to the next question. Yes, all of you got it or not? So we are moving to the next question, right? Yes, students, listen now. So we are moving to the next question. See, the reaction is given below. It's easy question. Anybody can tell me the answer fast. So reaction given below. Chlorobenzene with the metallic sodium and chloromethane. What is your answer? Anybody can tell me the answer. I am waiting for your answer. Respond fast. Hiba. Humaid. Yes. Respond fast. It's easy question. Is it Woods reaction? Is it Fittig reaction? Is it Woods-Fittig reaction? Tell me. Some people are telling wrong, some people are telling correct. Yes, you are asking to me, you tell the answer confidently, yes, it is correct. No doubt. Okay, we will see. Wait. So what theory is there? We studied 3 reactions here. Most of the students are struggling to understand this. It's easy only, very small, very easy portion. I'm just telling one small information here, just explaining that 3 area. Okay, listen. That's an area they are asking every time. See now. So we studied 3 reactions over there. You can remember these 3 reactions in a shorter way. There are 3 reactions. One is called Woods reaction. Another one is Fittig reaction. Another one is Woods-Fittig reaction. We studied in the class. I think I did today, right? Yes, listen. What is Woods reaction? 2 alkyl halide is there with me. 2 alkyl halide. On treating it with a metallic sodium. On treating it with a metallic sodium, you will get, in presence of dry ether, you will get alkane with a double number carbon. That is equal to Woods reaction. This is equal to, we can say, alkane with a double number carbon. This is RR plus 2NaX. This is equal to Woods reaction. 2 alkyl halide, treating it with a metallic sodium, in presence of dry ether, you will get alkane with a double number carbon. That is Woods. This is Woods reaction. Then what is Fittig reaction? So easy. Fittig reaction is like that. 2 aryl halide. Yes, 2 aryl halide. We are taking 2 aryl halide. For example, I am taking chlorobenzene plus metallic sodium. Again chlorobenzene. We are treating in presence of dry ether. In presence of dry ether. Yes, in presence of dry ether. You can remove this Na and Cl. You can connect these two. You will get biphenyl, or we can say diphenyl. This is equal to Fittig reaction. See, very simple, students. 2 alkyl halide reacting with the metallic sodium. You will remove NaCl. You will merge the left and right. You will combine this one and this one. You will get an alkane with a double number carbon. That is Woods reaction. 2 aryl halide combining in the similar condition, you will get Fittig reaction. Then tell me, what is Woods-Fittig? Can you guess that? Very simple. So 1 alkyl halide and 1 aryl halide we are combining. That is equal to Woods-Fittig. So in Woods-Fittig reaction, we are combining alkyl halide CH3Cl plus metallic sodium. Again aryl halide benzene ring with the chlorine. So we are combining in presence of dry ether. Yes, in presence of dry ether, you will get toluene here, CH3 with the benzene ring. Yes, you will get toluene here plus 2 NaCl. This reaction is coming under what? Wurtz-Fittig reaction. So this is so easy now. Just check the reaction now. This is Wurtz-Fittig reaction. This is Wurtz-Fittig reaction. So now coming back to the question. Here you have alkyl halide. Yes. Here you have aryl halide. Yes. So we are getting toluene. Yes. That is equal to option B, Wurtz-Fittig reaction. This is an easy question. This a question came in last year board exam. So remember. Okay. So we are moving to the next one now. I think all of you got it, right? This is easy one. I'm moving to the next question, right? Okay. Next one we are talking about a reaction of toluene with chlorine in presence of FeCl3 gives X, while reaction of toluene with chlorine in presence of light gives Y. Then X and Y are. What is the meaning? This is an easy question, normal question. This is also a last year board exam question. So we'll discuss now. Okay. See now. Reaction of toluene with chlorine in presence of FeCl3. Yes, I will write here. Reaction of toluene. Yes, this is toluene. This is toluene. We know that toluene is here. Chlorine in presence of FeCl3. This is a ring substitution reaction we studied. Chlorine will ionize as Cl plus and Cl minus. Cl plus will attack at ortho or para. This is ortho para directing. We know that toluene is ortho para directing towards ring substitution. So chlorine will attack at ortho. Chlorine will attack at para to get orthochlorotoluene as well as parachlorotoluene. You will get a mixture of orthochlorotoluene plus parachlorotoluene. This is parachlorotoluene. You will get a mixture of orthochlorotoluene and parachlorotoluene. No doubt about it. So toluene, on treating it with the chlorine in presence of FeCl3, you will get a mixture of orthochlorotoluene and parachlorotoluene. Anybody can tell me which is a major product? Please. Anybody? Please tell me. It's easy. Yes. Good. Major product is almost, you can say major product is equal to para product because of less steric effect. Now next one we are talking. Okay. So the next one, FeCl3. Yes, we are moving to do the next one, right? So with the chlorine presence of light, what is the answer with the chlorine in presence of light? Okay, this is CH3. Okay, this is CH3. Yes, this is CH3. Chlorine in presence of UV light. See, we studied this reaction before. Chlorine in presence of UV light, what will happen? All three hydrogen atoms are replaced by chlorine. This is equal to free radical substitution. This will give you free radical substitution reaction. Here, toluene is here. Hydrogen atom on the side chain is replaced by chlorine. If one molecule of chlorine is reacting, initially you will get monochloro like that CH2Cl. Okay, this is equal to 1-chloro-methyl-benzene. And again, if it is reacting, you will get to a second hydrogen also will be replaced by chlorine. You will get CHCl2. And again, if I am reacting, so again, if it is reacting with the chlorine in UV, you will get all three hydrogen atoms are replaced by chlorine. You will get trichloromethylbenzene. So this is the answer if you are getting with the chlorine in presence of UV. So repeating, chlorine in presence of FeCl3 under dark condition, you will get orthochlorotoluene and parachlorotoluene. Chlorine in presence of UV, under that condition you will get final product will be, you can say CCl3 with the benzene ring. So which is the answer here? Can you tell me? The answer, X equal to ortho and parachlorotoluene, Y equal to trichloromethylbenzene. The name of the compound will be trichloromethyl. This is trichloro, this is methylbenzene. This one is methylbenzene. CH3 benzene is methylbenzene. This is toluene, we call it as methylbenzene. Remember, this is methylbenzene. This is monochloromethylbenzene. This is dichloromethylbenzene. This is trichloromethylbenzene. So the answer, our answer is C. Okay. All of you got it? Yes. So we are moving to the last part now, last question. I think all of you got it, right? Are you okay with this question? Any doubt? Yes, we are moving to the next question now, right? Yes. Last one. This is a question came in recent board exam, so we'll discuss this question. Okay, I want the answer from your side. Identify A, B, C and D. This diagram is given. You can see the diagram there. How to decide A, B, C, D. Listen. Listen now. Okay. Yes, what's your doubt, Muhammad? Let me complete this. You can clear the doubt after that. I'll be available. Okay. Listen now. See now. This is C2H5Cl with the KCN and with the aqueous KOH. What's answer? This simple question we are going to do. We have to complete this. So we are doing it. Okay, listen. So we can say this is C2H5. C2H5Cl with the KCN. KCN, what is your answer? Nucleophilic substitution will occur. KCN, the major product is cyanide or nitrile. Cl minus is replaced by Cn. You will get C2H5Cn. This is compound D. With AgCN. AgCN is a weak electrolyte. Is not ionizing much. Is more covalent. So you can say you will get isocyanate. We studied before. You will get C2H5NC. C2H5NC. Right? Yes. This is C2H5NC. This is C2H5Cn. Then on treating it with alcoholic KOH. Yes. Alcoholic KOH. We know that aqueous KOH, I will tell first. Aqueous KOH will give you substitution. That's very, very important. Aqueous KOH will give you substitution. So you will get C2H5OH. Aqueous KOH will give you substitution. That is C2H5OH. Right? Then alcoholic KOH. We know that alcoholic KOH will give you elimination reaction. C2H5Cl is nothing but CH3CH2Cl. So from alpha carbon we will remove hydrogen. From beta carbon we will remove, from alpha carbon we will remove chlorine. From beta carbon we will remove hydrogen. Then we can develop a double bond between each other. So here you will get CH2 double bond CH2. That is nothing but C2H4. So this is equal to compound A. This is equal to compound B. This is equal to compound C. And this is equal to compound D. So which is the answer here? Compound D is nitrile here, compound D. Then compound C is isocyanate. Yes, carbylamine. This is called carbylamine or isocyanate. This is compound B. Compound B is alcohol. Yes. Compound A is after elimination reaction you will get compound A C2H4, right? So I think option A is your correct answer. Got it? Option A is your correct answer. Okay. All of you completed? Yes, very good. So these are the questions, very important area. And other than that, you have to go through the polyhalogen compounds, especially reactions of chloroform and others are little important. Because of lack of time, I didn't keep that question. So just go through it. So we'll be coming back to you tomorrow also. We'll have 2 chapters. So every day 2 chapters we will do. Don't miss it. We are here to help you in every aspect. Okay. So good night. So we are leaving now. Okay. Bye students. Anything else you can stay back and ask me in case if you want. Students then.